G'day YouTube, Warbles on a lot here. Nearly 10 o'clock at night and I'm having a little bit of rum. Because they say it's a bad flu season. I had a little bit of a sore throat today and I thought I might try to stave it off. Now in the background of that earlier shot, no doubt you saw this. What this is the fruits of my day's activities. I started to prepare for this at about 7:30 in the morning by thinking about getting out of bed. And then by about 7:45 I actually did get out of bed and prepared a load of Pinus radiata offcuts, which I've been in possession of for probably 5 or 7 years, and they've been sitting in a tin, and the tin has been, exposed to the sun, so they're not quite totally desiccated, but they were originally kiln dried and they've been kept in a dry place. And this is what I've come up with at the end of a day. Now I started out with 100 grams precisely, which I stuck in this 500ml varnish tin, which I have been using. Don't know whether you can see the inside of that or not in this light. As a Wood-Gasification canister with my concentrated solar thermal system known as the SunGas Mk-1-e. And this is the results of the 10th batch run, which commenced with 18 pieces, weighing 100 grams when it went in, and finished up with 19 pieces plus a pile of carbonised tar, which together weighed 69 grams when it came out. And because I'm a time expired nurse, I put my concentrated solar thermal gasometer onto 15-minutely observations, and I used my electric thermo probe to tell me that 674 degrees was the highest temperature that I saw. But the thing is, a pile of notes like that, while it may be scientifically useful, it's not visually communicative. A pile of carbonised wood with carbonised resins and tars which have migrated from the wood and then been cooked in the high temperatures, that's visually communicative. And there are occasions on which graphs can be visually communicative. This was my first attempt at graphing. Here we go, we have much more better lighting. So we can see we have time along the bottom scale. Then we have volume of gas in litres along the right-hand scale. And we have 3 different batch runs, 6th, 7th and 8th. And we have temperature in Celsius running down the left-hand scale. Yesterday it was inclement weather and I spent some time crunching numbers. And one of the things that I noticed is that I've been comparing apples with oranges. 100 grams of radiata, 250 grams of 100-year-old stringy bark. What's that? 180 grams of 2-year-old white gum. Doesn't actually tell me anything, really. And even on the 9th batch run, 171.6 grams of white stringy bark. So even though I've got electric thermo probe readings giving me the temperature of the bottom of the can as the gas rises. It's an arbitrary amount of wood that I've packed into the tin based on how much will fit. So it's not actually that useful. And then the other thing is, today's results, they were using the Mk-1-e. So for those of you in the know, that indicates something fairly different to the Mk-1. The Mk-1 was a 574mm Milo tin. There was a straight flare pipe. There was a single layer thermal insulation cosy. And the thermal insulation cosy was fairly short. The Mk-1-e, the thermal insulation cosy, was double walled with a triple layered lid. The Mk-1-c, that was the same, but it had a gasometer so I could collect the amount of gas. The Mk-1-d, the Milo tin failed, so I had to move to a 500mm varnish tin. The Mk-1-e, the major change with the Mk-1-e was that I extended the length of the thermal insulation T-cozy and I closed the heat leaks across the back of it. So I might sort of kind of leave the gasification can and the T-cozy alone at the moment. Load it with 100 grams of whatever kind of wood I want to test, measure the temperature of the bottom of the can with the thermoprobe, and sort of interpolate the temperature of the bottom of the can with the amount of gas and make a decision as to what sort of wood is the best sort of wood. But so far, it looks like radiata pine is going to be very hard to beat, because radiata pine today gave me 5.95 litres of burnable gas from 100 grams of offcuts of plantation grown, kiln dried, commercially useless timber. And so the reason I've been drinking a little bit of rum is because this is the graph of today's proceedings. As you can see, I've only carbonised about 30% of the wood, so if I add more heat to the process, I'm probably going to get more gas. And this is why radiata pine looks as if it's going to be so very hard to beat. Most of the day was spent sort of above 500 degrees Celsius, 5.95 litres of burnable gas, and only 500 mils of stuff that had to be vented because it would not burn. Let's just compare that with the Ranges Valley stringy bark. Admittedly, it was not as hot a run, largely because there was a fair bit of wind. But if you look at that, 8:30 in the morning till 1:30 in the afternoon, and it only really made 2.75 litres of gas, and 1 litre of that gas was the unburnable variety. That's why I've shaded the bottom of that graph with black. So yeah, either it needs a whole lot more heat to get any result from that, or it's just not as good for gas making as radiata pine. That versus that would have me driving to town and coming back with loads of radiata pine offcuts rather than chopping up dead gum trees. But we'll see what we will see, and time will tell, and we're really pretty much only at the beginning stages. And after a day like this, doing quarter-hourly obs on a Milo tin, being heated by a repurposed satellite dish, one is entitled to enjoy the better parts of the day. And with an experimental process like this, apart from the drinking and the smoking, one of the really nice parts is getting to flare off the gas. Methane and hydrogen, very clean, give you a lovely little blue flame. So clean you've really got to wait till it's dark to see it. And now, late at night, let's go and see if we can watch a bit. Okay, well, with my outside lights on, the camera isn't showing very much at all. So therefore, we resort to lighting things up with a torch. But as you can see, the gasometer is floating pretty high, 1.35 litres. But anyway, if I prop the camera there on the tripod and bring my fancy little burner over here, would you look at that? There we go, that works better. Well, that's sort of like the fruits of the day's efforts. The gasometer didn't quite sink perfectly level, so therefore there's probably 50 or 75 mils of burnable gas still in there. I think I'll probably leave it there. Hello possum and possumlet, how are you going? Anyway, before I spotted them, what I was going to do was suggest that perhaps the reason why I'm not interested in trying to burn any more of the gas is it's 5 degrees Celsius out here at the moment, and I don't feel like sticking my hands a foot deep in the water to sort out the lead weights at the bottom of the gasometer. So I guess with the torch shining brightly, isn't that an interesting formation? One of the good things about this system is that the tars get transported by the heat through the xylem and phloem cells from one end of the bit of wood, which is touching the bottom of the can and is therefore very hot, you know, like 500 or 600 degrees Celsius. The tars migrate and then they get sort of excreted, pushed out the end and drop back down onto the hot bottom of the inside of the can, where they react and form gas. So the hotter you get it, the better it works. Curious, isn't it? Like I said, yahoo yippee, just about 6 litres of burnable gas from 100 grams of off-cut pine. So, in the best of mad scientist tradition, I shall sit here and look at the graphs, ponder the results of the day's activities, sip on my rum, and try and figure out how to get more heat into the can so that I can maybe carbonise closer to 100% of the wood in the charge. Warbles on a lot to YouTube. Ciao.